If you have a fraction where you can factor the denominator, then you'll want to break this fraction up into the sum or difference of fractions using partial fraction decomposition. And so I'm going to take that s plus 2 over s plus 3 times s plus 4 and break this up into the sum of two fractions, a over s plus 3 plus b over s plus 4. I'm going to solve for a and b. I'm going to start by multiplying through by the common denominator, which is s plus 3, s plus 4, which will give me s plus 2 on the left side. My denominators cancel out. On the right side I get a times, here the s plus 3's cancel, and I'm left with a factor of s plus 4, and then b times s plus 3 because the s plus 4's cancel out. So simplifying the right side, I'm going to get as plus 4a plus bs plus 3b. And then combining like terms, I have a plus b s plus 4a plus 3b. We're going to set the coefficients equal to each other. And so I have my s terms. Coefficient on the left side is 1, and the coefficient on the right side is a plus b. That gives me 1 is equal to a plus b. And then for my constant term, on the left side of the equation I have 2, and on the right side of the equation I have 4a plus 3b. I'm going to solve this by elimination. I'll multiply this first equation by negative 3, and I'll bring that down here to give me negative 3 is equal to negative 3a minus 3b, so that I can add the equations together and the b terms will cancel out. 4a take away 3a gives me a, and 2 take away 3 gives me negative 1. A is negative 1, and I have a plus b is 1. So if I bring my a over to the other side, it tells me b is 1 minus a. If a is negative 1, I get 1 minus a negative 1, which is 2. B is 2. That tells me that I can break up this inverse Laplace into the sum of two fractions. I have negative 1, that's from my a, over s plus 3 plus the inverse Laplace of the value for b is 2, and that's over s plus 4. Now when you have s plus or minus some constant in the denominator, that tells you that when you apply the inverse Laplace, you're going to get an exponential function. In this first case, you have s plus 3 or s minus a negative 3. For the inverse Laplace, you can bring the negative 1 out, and you get negative 1 times the inverse Laplace of 1 over s minus a negative 3, which is e to the negative 3t, plus. On the second inverse Laplace, you can bring the 2 out and multiply by the inverse Laplace of 1 over s plus 4, which is e to the negative 4t. If your